Okay, second video, and here's our scenario. Read your scenario, pause the video, and sketch your graph. Okay, back for the answers. Christian is starting at the origin, and he's driving 20 meters per second west at a constant 20 meters per second, and then he turns around and he drives back to the origin at a constant 10 meters per second. So I have a very steep negative slope to start with compared to my more shallow slope in the end. The reason this one is steeper is because he has a higher rate of velocity. So he's headed west at 20 meters per second, negative slope. Then he turns around and he goes back east, so it becomes a positive slope, but he's not traveling as fast. So it takes him longer to get back. Okay, as far as our velocity time graph goes, we have a constant negative velocity, constant negative slope, constant negative velocity, directly followed by a constant positive velocity. And technically, this line should be about twice as far from this line, this base here, should be about twice as far as this line is from 0, because this represents 20 and this only represents 10. Okay, moving on to our acceleration. This is one of those weird ones, and I don't think you'll ever be asked this, but if I asked you to make an acceleration time graph, acceleration is the, hang on, my computer for some reason is about to restart. I don't know why. Okay, continuing on. The acceleration is happens right here. Acceleration occurs when you have a change in velocity. So that's a change in direction here. So if I were to calculate my acceleration, I would do my final velocity minus my initial velocity. And my final velocity was a positive number, while my initial velocity was a negative number. So I have my final minus initial, so minus a negative, divided by t. If I take a positive minus a negative, I'll end up with a positive number, because it'll be v plus the other v, right? So I end up with a positive acceleration. So just for this little bitty moment, it's like there's a little heartbeat there. Okay. Okay, moving on to the next scenario. Hide my answers. There we go. Okay, so Haley accidentally dropped her physics book off of a cliff. Haley accidentally dropped her physics book off of a cliff. So sketch your answers, pause your video, sketch your answers, and come back for mine. And by the way, let's do up and down. Okay. Here's my answers. So we're going to do up and down for positive and negative this time. Up and down. And still we have a positive acceleration or a negative acceleration. So where the book starts is the origin of the problem. And it starts slowly. As you drop it, it's going to accelerate downward, but it starts slowly and it speeds up as time goes by. So we should have a negative increasing slope. It's going down, but it's also speeding up. So here she's holding it, it's at a 0 velocity, and its velocity increases downward at a constant rate. Okay? To be exact, it's about -10. Okay, so we have a constant negative slope, constant negative acceleration. Okay, moving on to the next problem. Okay, they're getting a little bit harder. So here we have Philip. Read your scenario, sketch your answers. Alright, here are the answers. Philip threw a baseball straight up in the air and then he caught it at the same height. So if we call where the ball started the origin, then I can start this right here. Okay, so he threw it up in the air, so as it went up, it decelerated, right? Until it hit 0 for just a moment, and then it accelerated on the way down. So my position time graph would look like this. Alright, then my velocity time graph, to start out with, it had some positive velocity because he threw it up. So it had some positive velocity, but it slowed down to 0 at a constant rate, and then it sped back up in the negative direction. And to be exact, since he caught it from the same height, this number, let's say it's 5 meters per second, then this number would have been -5, just to let you know. We'll learn more about that later. And then, since it's slowing down in the positive direction, that's a negative acceleration. And since it's speeding up in the negative direction, that's still a negative acceleration, or constant negative slope, constant negative acceleration. So in case you didn't get that first part I was saying, it's slowing down in the positive direction, and it's speeding up in the negative direction. In both cases, you have a positive and a negative. Okay, moving on to the next problem. Okay, so now we have Laura, and she threw the ball up, but she failed to catch it, so it landed on the ground. So read your scenario and sketch your graphs. Okay, time for answers. So Laura threw it up in the air, and it slowed down on its way up, sped up on its way down, but when it got back to the origin, she missed it, so it kept going down past the origin, still speeding up, hit the ground, and she just left it there, so it stayed in that same position. So on the way up, it was slowing down, then it was speeding up, and then it went to 0. Hit the ground, went to 0. Now technically, and I didn't draw this very well, but let's say she threw it up at 5 meters per second. When it landed, really maybe I should have came down further, because it didn't land back at the origin where it would have been going -5. It would have actually been going something more than 5, like maybe 7 meters per second down. Okay? Constant negative slope, constant negative velocity, followed by 0 acceleration. Okay, I'm going to stop this video. That's part 2. You've got some hard ones coming up on part 3. Actually, you have some easy and some hard. And that includes things like this. So, come back for part 3.